Hello everybody. Namaskara everyone. As I always say, Andariki Namaskaram, Ellargu Swagatam and a very warm Vanakam to Vedantu JEE English channel. This is me, your master teacher Nabamita Bhattacharjee. And today we are here to complete the session Chemical Kinetics. Guys, I know that I was supposed to take you through chemical equilibrium and ionic equilibrium, but today we only had 2 hours left in the channel. Yes, after this, Durgesh ma'am is going to take care of some bit of organic chemistry, and then Nabamita ma'am is also going to take a session in the evening. So basically, we do not have space. So that is why I thought, why to leave the chance? Instead of that, I thought I'll do chemical kinetics because it's a very chotu chapter. Within 2 hours, we should be able to complete it, everyone. Yes, audible and visible. Thank you so much. So within 2 hours, we will be able to complete this chapter with some amount of PYQ, everybody. Now, are you ready to solve some questions as well as know every single thing? Yes. And I understand that even if you haven't studied this chapter, I promise you after today, you will be able to understand everything. And trust me, I'm going to take 2 hours. And within 2 hours, I will be able to complete the derivation. I will be able to complete the definition. I will be able to tell you top to bottom everything related to the chapter. So everybody, do we have your attendance? Quickly, like the session to show your attendance, to show me that yes, you guys are ready, steady, and yes, you guys are absolutely ready to let me know. Easy peasy biryani tasty at the end of the session. By the way, guys, let me also tell you one more thing here. I am just gonna go quickly to my, these are my PYQs here. But I am quickly go here. I'm gonna quickly go here and let me tell you that Vedantu has launched learning centers. So if you are preparing and you think that there is a little bit of gap in the preparation, you are still scared, you do not know how to appear for the exam, you still do not have the utmost level of confidence, then yes, Vedantu Learning Center is right for you, because you will be getting the highest amount of personal attention here, which will definitely empower your success. Because we know that majority of the time, guys, you have to understand this, right? That majority of the time what happens is, it's not just your academics that make you not clear your JEE exam. The content, there is an ocean of content on YouTube, everybody. Why do you still go for coaching? That's because you want to have that streamlined mentorship. You want to have that guidance in your life. Somebody who can tell you that, beta, do this, but you do that, then only you will be able to clear your exam. And that is why we here are near your city. We are in your city, my dear students, so that we can guide you, so that we can provide with the highest level of personal attention and make sure that your dream comes true with Vedantu. Because we have had more than 1,000 students clearing Vedantu each and every year, and this year it can be you. Here in Vedantu, you will be getting qualified teachers, you will be getting great content, you will be getting rigorous test practices and everything, everyone. So I do not know what are you waiting for. I don't know. Why not in Kerala? Okay, I think why not in Kerala? Because in Kerala, I guess you students, you did not fill the form. Remember, we gave you form and we told you that whoever is filling most amount of forms, only then we will come to the city. So from Kerala, you guys did not fill the form. What to do? If you would have filled the form, we would have been here. From Tamil Nadu, however, see, majority of the students fill the form, and that is why in Tamil Nadu, we have majority of the centers. We have Chennai, we have Coimbatore, we have Madurai, we have Trichy, we have Pondicherry. 5 centers in one state, everybody. So yes, you guys, you have to fill the form, guys. Let us know where we should come and we will come there. It's not in our hand, it's in your hand. And now one of the best part that Vedantu has, everybody, that is one thing that nobody else in this whole country can ever come and tell you. Nobody else is this guaranteed improvement in marks, everybody. We are so confident with our content. We are so confident with our academic team. We are so confident with our classes. We are so confident on our teachers that we can guarantee that your marks will improve. And if it doesn't, you can take your money back. And over 98% Vedantu students, they saw an increase in marks. Now, increase in marks, obviously, it's not just on us, right? I'm not going to sit in your exam. I can be the teacher. I can teach you. You have to meet me halfway through. If you do that, if your marks improve, guys, then that's it, the best thing. If it doesn't, you get to take your money back. So there is a win-win situation. There was no loss, not a loss of money at least, everybody. Yes. So guys, that's what it is, and here are the different courses that are offered in different Vedantu learning centers. The link is right below in this video, right below this video in the description box. You will find the form. So fill up the form and let our team know. Then our team will call you. They will explain you all the courses and everything. So just go ahead, get set, go and start your preparation, everybody. And as you all know, your favorite Vati, that is Shimon sir, he will also be coming to the centers. He will also be going to the centers. So if you want to meet him, then yes, this is another chance, everybody. With this note, I think we should start our session without much further ado. So guys, yes, very good, Rohit, very good. If it is not worth it, we would not be telling you here, but no worries, it's okay. Everybody has, everybody is entitled to their opinion. I understand, and that's why I said, right, there is a sea, there is an ocean of content on YouTube, but why is it that all the students, they still run to the coaching centers? That's because you need that streamlined guidance and mentorship. It's not just for content that you run, all right? Yes, but anyway guys, chemical kinetics. So what is it that in this chapter we read about? In this chapter, we get to know about the speed of a reaction, the velocity of a reaction. That is what is studied in this chapter. Now this chapter is very closely also related to thermodynamics. It is very closely related to chemical equilibrium. But in the chemical equilibrium chapter and in the thermodynamics chapter, what do you learn about? In thermodynamics, you learn about the feasibility of the reaction. Is the reaction feasible or not? Can the reaction occur or not? And there you know that at delta G is equal to 0, it is equilibrium. Delta G greater than 0, the reaction can happen. Delta G less than 0, the reaction can happen. That is called as feasibility of the reaction. You understand if the reaction is going to happen or not. All right, everybody. In the chemical equilibrium reaction, you understand what is the extent of the reaction. Till what scenario can the reaction happen? Is the whole reactant going to get over, or a little bit of the reaction is going to get over? That is something that you study in chemical equilibrium, which we will continue maybe tomorrow. Yes, maybe tomorrow I'll be taking chemical equilibrium and ionic equilibrium. But in this particular session, guys, we get to know about the speed of the reaction. So yes, very good, Sanjay, very good. Looks like you already know. Yes, very good, Sanjay, amazing. Yes. Now what happens is, the first thing that you want to know about in this chapter is, guys, average speed and instantaneous speed. Speed bole to whenever we talk about speed, when we were chotu motu kids, right? But even when we were chotu motu kids, don't you know that we learned about speed? What is speed? Speed is total distance divided by total time taken, and that's exactly what is written here, isn't it? Average speed is a total distance traveled divided by total time taken. Yes, and what is instantaneous speed? Instantaneous speed is speed for a very small duration when you are taking, right? For a very small duration. That's when we use dx by dt, for a very small particular distance or for a very small time. That is why we are using dx by dt term. Am I right, everybody? Yes, is this clear to you all? This is clear to you all? Great. Okay. Then we move on and we want to understand the rate of chemical reaction, guys. So I just told you that in this chapter, what do we study about? We study about speed of a reaction, isn't it? Yes, so here that means we want to learn about the rate of chemical reaction. That means at what rate is the chemical reaction happening? Is it fast? Is it slow? How is it happening, right? That's what we want to know. And hence the definition is right here. It can be defined as the change in concentration. Guys, when we are talking about a chemical reaction, do you think that a chemical reaction is like a car? Zoom, it will go. No. No. It's not a car, there is no engine. So how do we gather about speed? How do we gather knowledge about speed? Of course, in a chemical reaction, we have reactants, we have products. The reactants, what happens is they fade away, they disappear, and what are they forming? They appear as product. They are forming product. So that means that there is a change in the concentration, isn't it? Whatever you have taken, initially the concentration that you have taken, somehow there will be some change in it, and the product initially was definitely 0, and later on you will find some concentration of products appearing, isn't it? Yes. So basically that's what it is talking about. It says that it can be defined as the change in concentration of reactants and products in unit time. Why do we use this term unit time? To standardize. Once again, chemistry hai, science hai, standardization. Remember, in the last session we read about standard this, standard that, standard that, standard this, right? We kept learning about a lot of standard. So why is this standardization necessary? Because hey, it's science, hey, it's chemistry, precision, unit is very important. That's why we measure the change in concentration of reactants and products in unit time. Clear hai? So how do you write it in a little bit mathematical way? In this session we will also do a lot of mathematics, guys. Yes, sad. I also do not like mathematics, but what do you? Can't help it. It's there, so it's there. So rate of reaction is equal to change in amount of chemical species. Species bole to, what is species, guys? Species can be atoms, it can be ions, it can be molecules, etc, etc. So the change in amount of a chemical species divided by time taken for the change to occur. Yes, this, my dear student, is your rate. All right, everybody, guys, I need your reaction. Guys, I need your this thing. I need your interaction, please. Yes or no, say something. Otherwise, I will also feel sleepy. Should I just go? Should I just leave the session? I need your interaction. Let me know that yes, you understand. You don't understand. What is it? Let me know, everybody. Okay? So quickly, guys, everybody. Yes. Yes. No, Sanjay. Chill, Mari. You will see that everything will be crystal clear to you. In fact, I also have some questions that are related to activation energy. We will do it and you will be full confident. Don't worry. After this, just before your exam, we will also do another session where we will do 50 to 60 questions altogether. Okay? All understood? Yes, I thought so. Till here, nobody should have any doubt. Actually, so now when I'm talking about rate of change, rate of this. So that means in a chemical equation, what must be happening, guys? Do we all agree to the fact that here what exactly is happening is reactant is forming product? Do we all understand that reactant is forming product? Yes? Yes, guys? Very good. Okay. So that means that here, see what I'm doing is RAV. AV means average rate. Okay, we will study about average rate and instantaneous rate in a while. But here, take a look at it. So I want to write the average rate. RAV is equal to minus delta. Okay, this is your delta R. Why have I put this square bracket? This square bracket, my dear students, it signifies concentration. Yes, it signifies concentration of a species. So here we are writing R means concentration of reactant divided by delta T. Okay. And here, do you guys notice that I have also written a minus? A negative sign is here. Yes. A negative sign is here. Why do we have a negative sign, everybody? The negative sign signifies, it tells us, it speaks to us that hey, the reactants, they are going to disappear in some time. That means they are decreasing, isn't it? Yes, because it is decreasing, that's why there is a negative sign. See, similarly or unlike that, for the product here, we have not mentioned a negative sign. That means the product is going to appear, right? The product is going to appear, everybody. Yes. Achha, when I have written delta here, delta means what? Whenever we write delta, everybody, even in the thermodynamics chapter, when we wrote delta H, delta G, there is a possibility that you have subtracted one G minus another G. There is a opportunity that you have subtracted one enthalpy from another enthalpy. Similarly, when we are writing here delta R, that means that from one reactant, from the initial reactant, we are going to the final reactant. Yes, and here also time T2 and T1. That means that you are subtracting two concentration of the reactant and you are subtracting the time that is being taken. Yes, guys, are we all clear here also? Yes, great. Achha. Now something that you have to really focus here is that something that you have to really remember, guys. This is important. For the rate of a particular species, if you just want to find the rate of a particular species, for example, let's suppose that sodium plus chlorine, yes, what do they form? They form NaCl. Now, if you want to find out the rate of just sodium, you are not going to divide it by the coefficient. What is coefficient? The number that you write just before the symbol, that is 2Na, 2H2, 2O2. This 2 thing that I'm saying, this 2 is the coefficient that you do not divide. But if you are writing the rate of whole reaction, guys, the whole reaction, then yes, you will have to divide it by the coefficient. Till here, I suppose nobody has any doubt. So now let us take a general reaction. A general reaction as usual is going to be small letter A, capital letter A plus small letter B, capital letter B, gives out small letter C, capital letter C plus small letter D, capital letter D. Imagine that this is our general form of reaction. Okay. So all these small letter that we have, yes, what will we call them? They are your stoichiometric coefficient. What do we call it? Stoichiometric coefficient. Okay. All right. Stoichiometric coefficient is the small letters, everybody. Okay. So how do you write the rate of a reaction? Guys, everybody please pay attention. See, I have written rate of reaction. I did not write rate of a particular species, right? I haven't written rate of a particular species, and because I have written rate of a reaction, that means that I will be dividing it by the stoichiometric coefficient, which is -1 by A. Small letter A is the stoichiometric coefficient, so -1 by A, delta concentration of A divided by delta T. Similarly, -1 by B, because once again A and B, these are your reactants, so disappearance, minus sign is important. All right, but if you come to the product side, see, you have not mentioned negative sign at all. Both of them are positive. Why? Because these guys are appearing. They are not disappearing, they are appearing, everybody. Yes, so here you will not be mentioning the negative sign. Also, by the way, guys, because it is rate of reaction, reiterating everyone, you are going to divide it by stoichiometric coefficient. You have to, bacha. This is a rule, okay? For the rate of reaction, you have to understand, because, okay, there are two cases, right? There are two cases, everybody. I'll tell you, Sanjay, I'll come to that, okay? I'll come to that in a while, okay? I will come to that in a while. Okay, I'll come to that in a while right now, but just listen to me. I'll give you two cases where the stoichiometric coefficient can be 1, stoichiometric coefficient cannot be equal to 1. If it is 1, then you don't need to write it. But if it is not 1, then you have to understand that you are taking different measures of each reactant and different amount of different, moles of products are formed, isn't it? So you need to balance it, bacha. You need to balance it, and that is why you are dividing it, okay? That is why you are dividing it. All right, everybody, cool. Now, guys, let us take a look at, see, now if I want to write it only for one particular species, if I want to talk to you about rate of disappearance of A, if I want to just talk to you about rate of disappearance of A, then what is it going to be? See, right here, I am not dividing it by the stoichiometric coefficient. Am I dividing it by the stoichiometric coefficient? Not at all, because I am talking about just one particular species, that is the reactant A. And if I want to write about rate of appearance of D, here also I am talking about one particular species in the product section, hence I am not dividing. So till here, I hope nobody has any doubt, everybody. Yes, guys, are we all clear? Sanjay, I hope that your doubt has been cleared. Yes? Okay. Chalo, guys, moving on. Now let us understand what is average rate. Bachos, I know for a fact that average rate is something that you have studied from your class 8 standard, because even before screen is blurred. Oh, that's because I'm moving, so the camera takes a little bit time to focus up. Okay. Yes. Why the rate of disappearance is negative? You tell me. You have answered your question in the chat itself. Rate of disappearance, it is disappearing. If something is disappearing, that means from the initial concentration you are subtracting it, and that is why we use the negative sign. Okay, all right, ठीक है, चलो. Now, average rate is something that you probably know from the very childhood, everybody, because I also used to teach you guys in your, 8th standard, 10th standard, 9th standard. So yes, I've taught everything, guys. From class 6 standard to class 12 standard, I've taught everything in Vedantu. It's an amazing deal for me because now I also know that you guys have studied in your 8th standard what is average rate, right? Haven't you studied, everybody? You have. So the rate that is measured for a longer time. What is average, guys? Usually, how do you find average? Yes, if I want to tell you that find the average of the whole class, what will you do? Add for Sanjay, add for God, add for Tanishka, add for this, add for that. Everybody you will add and then divide it by the total marks, isn't it? Yes, that's how you will find average. Similarly, here also you do that. Here also, the rate is measured over a long time interval and it is called as average rate, average. No, did I write here? Yes, the rate measured over a longer interval of time is called as average time. No, it will be average rate. Okay, it will be average rate, everybody. So R of AV is equal to delta of D. Let's say that D is one of the species in the product. So I've written delta D divided by delta T. Guys, are we clear with average rate? Are we clear with average rate, everybody? Yes. Yes, are we clear with average rate? Yes, we are. Okay. Now here I do not know why I have a empty space. Maybe I would like to copy it later. That's why maybe I have written it. Yes. Okay, guys. Yes. ठीक है. Yes, guys. Thank you, Jeevan. Thank you so much, Iron. Yes. Why there is no minus sign there? Because bacha D is product. You guys are again and again. Everybody, you guys are getting confused. Everyone. Okay. See. Why is it this thing? Because our in general chemical equation that we like to talk about is AA plus BB forms CC plus DD. So D is a product, isn't it? Product will appear. If it is appearing, then positive sign. If it is not appearing, then negative sign. If it is disappearing, then negative sign. See. For if I want to find RAV of A, then I will write minus delta A divided by delta T. If I want to write RAV of B, then I will write minus delta B divided by delta T. But if I want to write RAV of C, then I will write delta C divided by delta T. Is this clear, everybody? Is there any more confusion about the minus and the positive sign, everyone? Just because it is disappearing. See, in the examination hall or in the whole chapter, you can't continuously write, right? It's science. We want to make people understand with symbols. Science is basically a very primitive language, In English, we like to use this happened, volcano erupted, tsunami came. No. In science, we will just show you like this and we will be like, volcano came. Tsunami was there was earthquake. Seismograph. What is seismograph? This is a graph. So with symbol we like to tell people, isn't it? Just like how in your WhatsApp you use the emojis and you're like, I'm smiley. You loved it, so you give those heart-struck images. So science is like that. We like to use symbols more, right? So here, continuously throughout the whole chapter, we are not going to write disappearing, appearing. No, we're not gonna do that. Minus disappearing plus appearing. Yeah, we're not poets, guys. There is no point of literature here, okay? We like symbols. We are like, that's it. Write one minus and people will understand that this is it. So getting it, everybody? That's why we use the negative sign. I understand that when we are trying to tell you that rate of disappearing, that already means that it is negative. So why are we using the negative sign? Because throughout the chapter, we are not going to use the rate of disappearing, rate of appearing, rate of disappearing, rate of appearing. We're not going to do that. One negative sign should suffice. One negative sign should tell you that, yeah, it is disappearing. Gotcha? Now, is there any more doubt, everybody? Now, is there any more doubt related to this? I really hope so not. I really hope so not, everybody. Is this clear, guys? Is this clear, everyone? This is clear? This clear? Yes? Yes? Very good, Sumati. Take some questions. Thank you for telling me how to do my job better. Thank you so much. Yes. I will take some questions, Baba. Questions are there. Chill. Questions are there. In the thumbnail only you can see, no? There are PYQs, there are tips and tricks. I'll do that. Don't worry. But first, let me at least complete some part. This is the very basic part of it. I have to complete some part of it, no? To be able to take care of the questions, because the questions will not come about average rate and instantaneous rate. But you guys have a doubt related to the negative sign and the positive sign only. Yes? Okay? So, chill. It will all be done. Okay? Now we come across instantaneous rate. Now you will ask me, but ma'am, we have just done average rate. Why is it that we need another rate? That's because average rate was for a longer duration, whereas instantaneous rate is for a very small duration. However, in chemistry, bacha, instantaneous rate is not very much used, okay? Because in chemistry we're talking about a whole reaction. What will I do knowing that the moment I started the reaction, after 1 second what would have happened? That's for research purpose. That's only for research purpose. I want to know that acha, what must have happened. I don't really want to know that, right? I want to know that after I added sodium and chlorine, end product mein what am I getting? So most of the time we will be talking about the average rate and not the instantaneous rate, okay? So whenever we are talking about a small duration of time, we will be using D, differentiation D. When you differentiate, what are you doing? Differentiation is for small part and small part and small part and small part. And then when you integrate, what do? You do small part and small part and small part and small part, and you add all of them. That's your integration. So in this chapter, we will be talking about differential rate law, rate equation, and we will also be talking about integral rate law, integration rate equation. All right. Yes, everybody. Yes. 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 All right, everybody. This is clear, guys. So this is your instantaneous rate. Now, guys, rate of reaction, right? Rate of reaction. Obviously, there is some unit that is there, right? There is some amount of unit, obviously. I mean, come on. Again, science, physics, chemistry, we have to talk about unit. So if you check it out, everybody, you will find out. If you check it out, just look at it, everybody. Have a look here. What do you see? What do you see? You see that R is equal to, R is your what? R is your rate of reaction. So your rate of reaction, we usually write it as minus dr divided by dt. Capital R here is the reactant, it signifies the reactants, and capital P here means the product. So dP divided by dt or minus dr divided by dt. So in the numerator, guys, what do you have? In the numerator, what do you have? Concentration. Denominator, ma'am, what do you have? dt. dt means time here, okay? So for concentration, what is the unit that you use? You use mole per liter, right, for concentration. And for time, what is the SI unit of time, guys? Seconds. So that means for liquids, you will be using mole per liter, second to the power minus 1. But if you have a gas, can you still use mole per liter? No. For gases, you will have to use pressure. So atm s to the power minus 1. Okay? atm s to the power minus 1. That will be for gases. Everybody, rate of reaction of units, I suppose that till here everything is clear. Okay? So now, guys, Sanjay, remember the question that you asked, Sanjay? You have asked me that, ma'am, why are we dividing it by a stoichiometric coefficient? So suppose you have two cases here. One case is where the stoichiometric coefficient is 1. If it is 1, that means for each and every species in the reaction, you have taken only 1 mole of that species. Am I right, everybody? Chinku sleeper, bacha, can you please see? Can you please observe that I'm teaching you a chapter that is named as Chemical Kinetics. Right now, I will not be able to tell you what to read in P block. Please wait up. I'll tell you later on, but not right now. You are somehow disturbing the class right now because we're talking about physical chemistry. P block comes in inorganic chemistry. You'll have to wait, but not right now. Okay? Okay. So here see, everybody has a stoichiometric coefficient 1. So why am I saying that it is 1, everyone? Take a look at it. Hg. If nothing is there, that means 1 mole of Hg would have been used. Nothing is there, that means 1 mole of Cl2. Nothing is there, that means 1 mole of HgCl2 has been formed. So that means here things are balanced. I do not have to do anything. So that means that I am not going to divide it by the stoichiometric coefficient. Make sense, everybody? Make sense, everyone? Very good. Okay. But In my case 2 here, stoichiometric coefficient is not 1. That means for every 1 mole of nitrogen, you require 3 moles of hydrogen to be able to form 2 moles of ammonia. Do you see it? It does not look bad. I mean, yes, the equation is balanced. Equation is balanced. But while I'm trying to calculate the rate of reaction, I need to be able to still make it all equivalent, and that's why I'm dividing it by the stoichiometric coefficient. Am I clear, everybody? Guys, can you please help with Chinku? I think he's not understanding. I have already replied to him, but he's still, continuously spamming. If any one of you can just help him with the important topics of P block, because I know that you guys come to my session, so you probably be knowing. Please let him know. Okay? All right. Okay. So guys, this is all clear now. Till here, I hope nobody has any doubt. Rate of reaction expression is over. Great. Okay. Now what happens is there are certain factors that affect the rate of reaction. Obviously, Baba. Obviously, rate of reaction will be affected by certain things, right? And certain things will not affect the rate of reaction. So let us talk about it. The nature and the state of the reactant, guys. Yes, even if you take a reactant in solid, or if you take it in liquid, or if you take it in gaseous, the rate of reaction will change. Why so? Do we not know, my bachus? Do we not know that gases are highly reactive, the solids are tightly packed? So how on earth do you think that they will not be affecting the rate of reaction? It is very easy peasy, biryani tasty, and very obvious that yes, nature and state of the reactants will affect will affect the rate of reaction. Correct, everybody? Great. Then what do we have? Concentration of reactant, as in how much, what is the concentration of the reactants that you are taking. That will also affect the rate of reaction. There is temperature, and we will talk about temperature coefficient. We will talk about Arrhenius equation. However, right now at just 32 minutes of the session, to introduce Arrhenius equation, it's slightly difficult. I will do it. Don't worry about it. We will have it. Okay? Then there is catalyst. If you use a catalyst, the rate of reaction, what will happen to the rate of reaction? The reaction will be faster. The reaction will be faster. However, a catalyst, as you all know, if you have studied chemical equilibrium even once, you would know that equilibrium does not get affected by catalyst, but the rate of reaction will definitely get affected by a catalyst. All right. And finally, exposure to light. So if there is a photochemical reaction, then yes, exposure to light will definitely affect the rate of reaction. Am I clear? Am I clear, everybody? Yes. Factors affecting rate of reaction, I hope that you guys are clear with. Okay. Now let us talk about the first factor that I spoke to you, that is nature of reactant. Take a look at it, everybody. Do you see here? What am I taking? See, I am taking, in both the scenarios here, I am taking water and water. Okay. I am taking water in both the scenarios. But I am adding a metal which is very highly reactive, that is sodium, and I know that when I make sodium react with water, this reaction is going to be super fast, very, very, very fast, and it will form a base and hydrogen gas will be liberated. Similarly, yes, a base will be formed and hydrogen gas will be liberated. However, if I add calcium instead of sodium, this reaction rate is going to be moderate and it is not going to be that fast. Clear hai? Yes? Clear hai? What should be the nature for speed of reaction? Mahesh, see, look at it. Look at it. I'm giving you the examples. Do you see how if you change the reactant, how if you change certain reactants, you will be having different rate of reaction, although one of the reactant was absolutely same, that is water and water. And yes, in the product side you are getting a base and a hydrogen gas, however, just because you have changed the metal, the rate of reaction changed tremendously. Did you see? Did you notice, everybody? Did you notice, guys? Yes? Did you notice, everyone? Yes? Very good, guys. Very, 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 very good. All right. Now, look at the state, everybody. Look at the state. I was talking to you about state, everyone. Look at the state, guys. So here, exactly same reactants. Exactly same reactant, everybody. We are taking 2 moles of iron. Yes, 2 moles of iron plus 6 moles of hydrochloric acid. It does form 2 FeCl3 plus 3 hydrogen. Okay. 3 moles of hydrogen. Hydrogen gas is being liberated. No problem about it. But In the first case, we have taken solid iron, that is an iron nail. Iron nail, you understand that, you have the tuck, 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 you hammer it down, iron nail. Yes, that iron nail we are taking. So in this case, the reaction is going to be slow. But the moment you take iron powder, iron filing, iron powder, the moment you take iron powder, the reaction becomes faster. Why? Surface area. The moment you have made it powder, the surface area of iron has increased, hence the reaction becomes faster. Easy peasy, biryani tasty. Can I get some EPPT in the chat box? And the physical state also. Yeah, bacha. From solid, when you're breaking it down, what will happen? Surface area. It is surface area only. It is absolutely surface area. The state is basically the surface area, obviously. Basically what I'm saying is a solid, it's this, and a solid that is powder. That means when you have powdered it, you have increased the surface area, isn't it? Exactly the same way, your intestine being plain and your intestine having microvilli, what is happening? Microvilli is single projection, so surface area has increased. That's it. You guys are absolutely right. Yes, it is surface area. And the physical state of the reaction, that is when it is solid phase, it will be slow reaction. But if you take the reactant in gas phase, you will get a fast reaction. Cool, everybody? Yes, guys? Yes. And of course, concentration. Rate of reaction decreases with decrease in concentration and vice versa. Tell me something. Do you remember in the day before yesterday's session, everybody, what did we do? Preferential discharge theory and product of electrolysis. Do you remember? Do you guys remember? Product of electrolysis, preferential discharge theory. And do you remember that the product somehow changed in electrolysis when we had taken concentration, when we had taken concentrated brine solution and when we took dilute NaCl solution, there was a difference in the product, isn't it? And there was obviously a rate of reaction difference also. Yes, because now when you have taken a dilute solution, the rate will obviously change. So see, you get to see these examples, the examples of the concepts in different chapters as well. So everybody, easy peasy biryani tasty, am I right? Okay, now we come across differential rate law. Guys, these are all my handwriting, but what I did was, before this class, I wrote everything so that I don't take much time while writing it. And then the session becomes longer. So that's why I wrote it. I'll be giving you the PDF in the Telegram channel. Don't worry about it, okay? So that's why this is all my handwriting. You can actually correlate and see that this is my handwriting. So I wrote everything so that, we don't waste our time so much. Okay? Alrighty. Now we come across rate law. Guys, differential rate law, differential rate equation, or just rate equation or rate law means the same. Okay, it is one and the same. We are not talking about anything else. We are talking about the usual rate law. Absolutely right, Happy Mowgli. That's why I wrote vice versa. Vice versa means that if you increase the rate of reaction, if you increase the concentration, rate of reaction will increase. Of course. Yes, great. Okay. So rate law. What is rate law, guys? The rate law is basically, how you write. Do you know how, in our days when we were young, and so the marking scheme used to be a little different, isn't it? The marking scheme used to be a little different in our board examination. So what we used to do was to just, make the answer look a little bigger. We used to write that this is nothing but, just to use the word count a little more, right? So that's what I was just doing. Rate law is nothing but, it is an expression in which the reaction rate is given in terms of molar concentration. So till now we saw that rate of reaction, we were talking about what? Just concentration. But now we're going to talk about molar concentration of the reactants with each term raised to some power. What is that power? That power is going to be your stoichiometric coefficient. Okay? Alright? Yes, which may or may not be the same as the stoichiometric coefficient. Yes, that power is usually stoichiometric coefficient, but sometimes it might not be equal to stoichiometric coefficient. That is why we keep telling you, everybody, that is why we keep telling you that order of a reaction, which we will study in a while, right? Order of a reaction, my dear students, is what? Order of a reaction is experimentally calculated. For an elementary reaction, there is a chance that the order of the reaction is going to be same as the stoichiometric coefficients, but for a complex reaction, it is definitely not the case. You will find that always it is not same, everybody, and that's why this sentence makes a lot of sense. This sentence, everybody, that I have written here, that which may or may not be same as stoichiometric coefficient of the reacting species in balanced chemical equation. If you did not understand anything from this paragraph, no worries, just look at it. So again, everybody, we have the general equation, that is AA plus BB forms CC plus DB. How do you write the rate? Rate will be proportional to A to the power X and B to the power Y, right? Rate will be what? It will be proportional to A to the power X, B to the power Y. See, I have not written A and B. I am writing X and Y. Why am I writing X and Y? Because like I said, this X and Y may or may not be equal to A and B, okay? Rate, now to remove this proportionality sign, I will need a constant, and that is why we have a constant which is K. K is called as a rate constant, which is A to the power X, B to the power Y. Now if you differentiate it, because see, differential rate equation, I'm not saying that this is just rate law. If we are talking about differential rate equation, that means some differentiation would be necessary here, isn't it? Some differentiation will be necessary here. So minus d R by dt is equal to K A to the power X, B to the power Y. Okay. Is there any rate equation with concentration of product? Same bacha. Same, exactly same you can write. See, what you can do is minus dr by dt, right? Now you can write it as dp divided by dt is equal to K, let's say C to the power U and D to the power Z. This will be the differential rate law. That's it. Exactly same for minus dr by dt. If this is the case, for dp by dt, it is going to be this. Yes, got it, Mahesh? Understood? Yes. What is the weightage of this chapter? You will surely be getting one question or two questions from this, okay? Sorry guys, I had to drink water. Do you guys also drink water? Please do drink water, okay? Very important. Okay, all right guys. So moving on from here now, what are the characteristics of this differential rate law? What are the characteristics? Why do we use it? What do you get from here? You understand that if the value of K, that is rate constant, yes, if the value of A, please cover all the PYQs on 2024. Yeah, we will do that. Of 2024, we will do it. The first attempt 2024, we will do it. Yes, but 2023 and 2022, we will not be able to complete everything. So I suggest you can get the book. Yes, Milan, I'm lazy. Yeah, I can't fill the bottle again and again. So once I fill it, I only fill this bottle twice in a day. So 4 liters is covered. Okay. You have to drink 3 to 4 liters of water in a day, right? So I complete this bottle twice. So I think I'm done for the day. Anyway, guys, moving on, everybody. See, look at the characteristics of this differential rate law. Okay. Number one is that if you have a large value of K, that is rate constant. K is the rate constant, everybody. Okay. If you have a large value of K, that means the reaction is also happening quite faster. Okay. At a particular temperature, at any given particular temperature, the value of K is constant for a reaction. That is why it is a constant, right? What did I say? I told you that it is rate constant. So that means that the value of K is going to be constant, okay? And if you change the initial concentration of the reactants and the product, nothing happens to the rate constant. The rate constant is independent. The rate constant, it's a constant. It is independent of the initial concentration of the reactant and the product. Okay, all right. And see, here I have written this. Here I have written, everybody, that the exponents x and y may or may not be equal to the stoichiometric coefficients, that is A and B of the reactant. And once again, I'm telling you, for an elementary reaction, however, you will find generally that X and Y are equal to A and B respectively. But you will not always find it that it is exactly the same. Am I clear, everybody? Yes, guys, am I clear? Yes, bacha, JEE pattern almost remains the same. Okay? JEE mains pattern remains the same almost throughout the years. Okay? All right. Money Chinna, actually I have already, you will find it, although it's an old video. Every year we will do the same video, we will make the same video, but that will take a little time. So if you are less on time, you can watch the previous video. I have done a session on periodic trends in just half an hour. I've done it, so you can watch that video. Okay? Alright, so you can watch that video. Chalo guys, moving on everyone. Now let me give you some examples. Okay, let me give you some examples here, everybody. See, for this particular reaction, if you see, if I take 2NO forms O2 and 2NO plus O2 forms 2NO2, right? If I take this reaction, then here rate will be NO to the power X, O2 to the power Y, okay? So my rate is going to be K NO to the power 2. See, here it is equal to stoichiometric coefficient, and O2 to the power 1. Stoichiometric coefficient of oxygen is here 1. So X and Y here are equal to stoichiometric coefficient. But it is not always the case. Now look at this, everybody. Look at the next example. CHCl3 plus Cl2 if I take, and if it forms CCl4 plus HCl, here my rate is supposed to be proportional to CHCl3 to the power X and Cl2 to the power Y. But here what happens is K CHCl3 to the power 1, Cl2 to the power half. Cl2 to the power half, my dear students. It is to the power half. So do you notice that X and Y can be equal to A and B, might not be equal to A and B. And this is experimentally determined. Okay, it is experimentally determined. Am I clear, everybody? I hope till here you do not have any doubt. Do you have any doubt, guys? This is all clear. Now we're going to move towards order of reaction. You let me know. You let me know, everybody. Does anybody else have any other doubt here? All clear, guys? All clear? Thank you, Tanishka. Yes. How can you find order of such reaction? Yes, very good question. Yes, very good question. So you cannot really find it, okay? You cannot really find it. It is experimentally determined. Like I said, it is experimentally determined. However, in your JEE Mains question, or JEE Mains, definitely in JEE Mains question, you will only be mostly getting elementary reaction. So you will have to know certain of the reactions, and you will have to know what is the order. Okay? There is no other way, because it is experimentally determined and you do not know how to find it right now. It is not even there in your syllabus. Forget about it. Just know certain of the questions and you must know what is their order. Okay? That's it you can do, Sumati. That is the maximum that you can do. Nothing else you can do. Okay? Chalo. Now guys, let us come to order of a reaction. So what is order? Order is basically the sum of the power of the concentration of the reactants, sum of the power of the concentration of the reactants in the rate law expression. That is called as the order of the chemical reaction. So if X plus Y, you know the exponents that you had, those exponents which are experimentally determined, once again, those experiments which are experimentally determined, those exponents which are experimentally determined. So X plus Y is your order of reaction. If X plus Y is equal to 0, then it is a 0 order reaction. If X plus Y is equal to 1, then it is a first order reaction. If X plus Y is equal to 2, then it is a second order reaction, and so on and so on. So forth. If X plus Y is equal to N, then it is the nth order reaction, everybody. Okay, guys? Yes. Now let us take, so remember that I told you photochemical reaction. Yes. Factors affected by factors that affect the rate of reaction, and I told you that exposure to light. So this is a clear example of that exposure to light, everybody. And here you see H2 plus Cl2, H nu when it hits, you get 2 HCl. Okay, you get 2 HCl. So this is the photochemical reaction here. How do you calculate the rate, everybody? Let me know in the chat box. So rate is going to be equal to K H2 to the power 0 Cl2 to the power 0. This is a zero order reaction. What are the permutation and combinations that you have? What are the permutation and combination that you have? It has to be H2 to the power 0, Cl2 to the power 0, and anything to the power 0 is equal to 1. That means rate, my dear student, is equal to K. Rate is equal to the rate constant, everyone. That means that the concentration of reactants are not changing with time. What can we say? We can say that means the concentration of the reactants are not changing with time. How can you say that? Okay, concentration of reactants are not changing with time. That's because basically, you know, equilibrium chapter, when we read about equilibrium chapter, okay, how you said, Mahesh, once again, it's experimentally determined. You have to know. That's why I'm teaching you. You have to know. Yes, you can remember, you can memorize it. For the most important reactions, you can memorize it. Okay, there is no other way. It is experimentally determined. You have no idea how to find out. It is not there in your syllabus. It's a vast thing to know. So forget about it. Just memorize. That's your easy peasy option. Okay? Alright? Yes, Mahesh. I'm telling you again and again. It's experimentally determined. You cannot calculate it. You cannot find it out on your own. It is experimentally determined. For certain of the reactions, you can memorize it. Yes. However, in JEE Mains, I do not think that they will ask you to find the order. They usually ask you about T-half. They usually ask you about activation energy. They usually ask you about, about Arrhenius equation and all of that. Okay. Chalo, I will do that. Okay. You know what, guys? Let's do this. Today I do not have it. I'll do one thing. I'll give you some of the most important reactions as per the point of view of JEE, and I'll tell you the order of the reactions. Okay? Can I do that? Yes, Vishnu Priyan, you can definitely watch it. It is important for NEET also. Okay? So the concentration of the reactants are not changing with time. Now, guys, when we read equilibrium, you will understand that what is happening. You know, imagine a man going in the escalator. Escalator, you all know. Milan, if you are watching the movie Jawan, should I kill Shah Rukh Khan in the beginning of the movie? Huh? Or can I take the dad Shah Rukh Khan right in the beginning of the movie? For Arrhenius equation, you have to wait, Baba. You have to wait. We haven't done half-life. We haven't done pseudo first order reaction. We do not know what is molecularity. How can I directly go to Arrhenius equation? I'll take it. It's there. Chill. It's there. Imagine it's a movie. Chemical Kinetics is the movie. Your hero, all the characters will be introduced slowly and steadily. Patience, bacha. Patience. Okay? Yes. So now, escalator, you guys know what is escalator? You know those moving stairs? The moving stairs in a mall, right? Moving stairs in a mall. So the escalator, suppose it is coming down, okay? But you are that, badmash bacha, okay? You are, you are a little mischievous kid. So what you want to do is, that escalator which is coming down, you don't want to come down through that. You want to climb up and see. You want to climb up and see. So what will happen if you try to climb up and see? For a certain point of time, you will be at the same place, isn't it? You'll be like, hi, that one is coming down and you're trying to go up. But you will be almost at the same position, right? That's kind of like this what is happening. That is sort of like this that is happening. The concentration of the reactants does not change with time. We will read the equilibrium chapter and we will get to know about this more. So hold on to your horses. Yes, all right. Yes. We will talk about that later. Money, don't get confused. Just know that for zero order reaction, this is how it is. That means that rate is equal to constant. That means that the concentration of reactants are not changing with time. When we do that equilibrium chapter, that time I will teach you this even better. Don't worry about it, okay? Yes, guys, very good. Now let's go to first order reaction. Shall we take another example? Let us take another example. So here, let's suppose that we have an example of N2O5, dinitrogen pentaoxide. If we take, so here we will get 2NO2. 2 nitrogen is done, O2, 2, so 4, okay. Plus, what will we get? Plus O2, it cannot be half O2. Can I take half O2? Half O2 will do, yes? Half O2 will do, okay. So here, my rate is supposed to be what? Rate is supposed to be K and N2O5. Now, let us say that we want to write here 1. Why are we writing 1? Why are we writing 1? Exponent. Exponent. Remember, the exponents, once again everybody, experimentally determined. You cannot calculate it. No, acha. Chalo, let me explain this even better, okay? For a first order reaction, everybody, you know that x plus y is supposed to be 1, isn't it? X plus y is supposed to be 1 for a first order reaction. That means that either my rate can be, okay, either my rate can be K, A to the power 1 and B to the power 0, or it can be K, A to the power 0, B to the power 1, right? Or it can be K, A to the power half and B to the power half, right? Right, everybody? Am I right, guys? Am I right, everybody? Yes or no, guys? Yes or no? Yes or no? Yes or no? Very good. Exactly. So now I'm just going to rub it. This is for your sake to understand this. So these are the things that can happen, right? These are the things that can happen. So similarly, if I have K N2O5 to the power 1, that means that the rate is equal to 1, right? That means that here the order of the reaction is also first order. Am I right, everybody? Yes? 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 Yes, very good, elastic user. Very good, very good. That can also happen, Supriya. That can also happen, but I'm not trying to complicate it because it's, we know we want to go a little faster. This is your last lap of the revision, right? We can do that also. That is also possible. That is also possible. Absolutely is possible, guys. Absolutely it is possible. Do you remember what is the difference between molecularity and order of reaction? If I have told you that order is experimentally determined, right? Order of reaction can be 0, 1, 2, 3, fraction or negative. Molecularity cannot. So yes, it is possible. Order can be 0, order can be first, order can be 2, order can be 3, order can be fraction, order can be negative. Order can be negative. It can be all of these, everybody. So yes, it can be. Whatever you are saying, Mahesh, possible. Yes, who else? Was it Supriya? Yes, it is possible. Yes, it is possible. Absolutely possible. But I'm just trying to make it easy and simple for you. So you guys understand that order can be this. Order can be this. Absolutely, it can be this. No doubt about it that it cannot be this, okay? It can be this. So till first order here, everybody, are we all clear with this? Yes. Are we all clear with this, guys? Let us go to the second order. Chalo, let us go to the second order now. In second order, what can be possible, guys? Chalo, let's come to here, okay? Yes. Let's come to this side, guys. For second order, my dear students, my rate can be K either A to the power 2, right? I can write it as A to the power 2, or I can have K A to the power 1 and B to the power 1. Am I right? Yes. Or there is a possibility that it is K B to the power 2. Am I right, everybody? Very similar to the first order. Exactly. Now, if I take an example, let us take an example. Let's say that our example is, this is one example that you will continuously see a lot of time, everybody. 2HI forms H2 plus I2. By the way, this is the reversible reaction. This is an equilibrium, everyone. Yes. So here what happens? Your rate is equal to KHI to the power 2. And this is your second order reaction, everyone. Okay, this is your second order reaction. And once again, everybody, I've just told you that can order of reaction be fractional? Yes, it can be. Didn't you see? Remember KCHCl3? I showed you, right? Yeah, see. Everybody, look at it. Do you guys see? Notice here. See, Cl2 has half, everyone. So 1 plus half is what? 1 plus half is what? 3 by 2. So yes, the order of this reaction is going to be 3 by 2, everybody. It can be fractional as well. So I suppose Till here, I guess that none of you have any doubt. Now here is a question for you, everybody. Let us answer this, everybody. Chalo, let us answer this, guys. Tell me, everybody, the sum of powers to which concentration terms are raised in the rate law is called dash of the reaction. Tell me, read this. Very good, Mahesh. Very, very, very good, everybody. Yes, yes, yes. The what is the actual? That is the actual exponent. Half is the actual exponent, bacha. That half is only the actual exponent. Okay. Very good, everybody. I can see that majority of the students have answered it right. Order is the correct answer. Yes, this is just warm up, guys. This is just warm up. Okay. Tough questions are also coming. We will be doing some JEE Main PYQ 2023 questions also. We are doing 2022 questions also. We are doing. Don't worry about it. It's just warm up. It's just warm up. Very good. Sumati, Rovin, Happy Mowgli, Milan, Varguna, Money. Very, very, very good, everybody. Chalo, guys. Next question. The rate constant has the same unit as the rate of reaction for a dash order reaction. Anybody? Yes? Anybody? The rate constant has the same unit as the rate of reaction for dash order reaction. Absolutely right. Jeevan, Mahesh, Apple, Supriya, Nikhil. Well done, guys. The correct answer is 0. A big 0, not hero. Chalo. Now let us take a look at a JEE Mains 2023 question. Shall we do it, everybody? Shall we do it, guys? Yeah? Let's do it. What do you all say? Are you all with me? Are you all with me? Here is a question. This is a JEE Mains 2023 question. Everybody, let us try and solve it. So, A is the reactant and B is the product, everybody. Okay, A is the reactant, B is the product. If formation of compound B follows the first order of kinetics, and after 70 minutes, the concentration of A was found to be half of its initial concentration, then the rate constant of the reaction is X multiplied with 10 to the power minus 6 S to the power minus 1. The value of X is what? Nearest integer you have to calculate. Okay, nearest integer you can, when stoichiometry coefficient become power of concentration. Nikhil Singh, when it is an elementary reaction. In case of an elementary reaction, we do see that the coefficient becomes the power. Okay, the stoichiometric coefficient becomes a power, but not generally, not always, guys. Okay, not always, not always, everybody. I really hope that you are paying attention. The key word is not always. So, guys, have you read the question? Have you read the question? Now, so here is a formula, everybody. Please pay attention. The formula is K is equal to 0.693 divided by T half. Okay, this is a very simple and easy formula. See, the question says if the formation of compound B follows the first order of reaction, this is the first order of reaction, and after 70 minutes, the concentration of A was found to be half. 70 minutes. That means at 70 minutes, the concentration was half. That means that 70 minutes is the T half. 70 minutes is the T half, everybody. So here what do we write? We write 0.693 divided by 70 minutes. So 70 into 60, we want it to be in seconds, right? We want it to be in seconds because see, S to the power minus 1. That's why I'm multiplying it, okay? So 0.693 70 into 60. What I can do is here, check it out, everybody. I can write it as 6930 multiplied with 10 to the power minus 6. If I do 10 to the power minus 6, just so that I can manage it, I can manage with the units. And here if I write 7 into 6, calculate this and tell me, guys. Calculate this and tell me what is the answer that you are getting. Calculate and tell me what is the answer that you are getting, everybody. Money, you calculated already? Did you calculate it? Yes? 164.4? Alright, so 164.4 into 10 to the power minus 6. However, the question says nearest integer, guys. Nearest integer. So 164.4 into 10 to the power minus 6. That means the nearest integer is going to be 165 into 10 to the power minus 6. Sorry, not 16. 1 second. I think I deserve an award to make my slides so difficult. 165 into 10 to the power minus 6. Yes, that is the answer. So the value of X is 165. Okay, the value of X is 165, guys. Cool, hai? Are we all clear? All clear? Very good. Chalo. Next question. Do we have another question here? Acha, no, nothing. Chalo. Sorry, guys. Something is in my eyes. And once again, I hope it's not the infection that is. Money, actually, you know what? 164 was the 164 should be the correct answer. However, I do not know why NTA had released the answer as 165. NTA had released the answer as 165. So, you know. So yeah. The answer that was released was 165. So you can either write 165 or you can write it as 164. All right. For now, chalo, we can write it as 164 also. But it was released as 165. So maybe there was some calculated. When I calculated, you got 165 only. You got exactly 165. Chalo, you know what? Let me calculate it in my calculator once. Okay. What was the this thing? Let me calculate it one. It was 0.693 divided by 70 into 60. Guys, even when I am calculating, it is coming as 165. It is coming as 165. So that is why 165 is the answer. Everybody, you did not, you know what? You don't have to do this. I did this just to make it easier. But if you just calculate this part, just calculate this 0.693 divided by 70 into 60 if you do, then you are getting it as 165. Maybe if you do this, then you are getting a little different. But I guess this is not even the answer. The correct answer is 165 only, guys. So 165, you don't have to round off. Okay? All clear? Yes. No, it comes as 165, not 164. Thank you so much. Yes. Okay? Both ways say 165 only. Both ways it's 165, guys. I did not calculate it. I asked you to calculate and I took your answers for, I took your answers for granted. Maybe that's why it has arisen. But it should be 165. The answer is 165. Guys, calculation part, I'm leaving it to you because, that's a practice you have to do. I am not very good at mathematics, I'll be honest. I'm very bad at mathematics, in fact. So that's why I cannot calculate it very fast. I have to use a calculator, right? But you have to do it, guys. You have to do it, okay? There is no other option. You have to do it, okay? Alright, guys. Now let us talk about, everybody, order of reaction. Let us talk about the units of K. You will be surprised to understand, or you will be surprised to know, those of you who are studying it for the first time, you will be surprised to know that the units of K for each and every order of reaction, it is different, everybody. Chalo, let us calculate it. So we know that we have a general equation, everybody. Our general equation is AA plus BB forms CC plus DD. And our rate is supposed to be A to the power X, B to the power Y. So, for the rate constant K, we can write it as the rate divided by A to the power X, B to the power Y. And our units of K is supposed to be concentration divided by time, concentration divided by time, divided by concentration raised to the power X plus Y. So, shall we start and calculate for order of reaction 0? Yes. Let us try and calculate it for 0 order, okay? Yes. Salt analysis, yes, we will do it. Salt analysis is not a very important chapter. The weightage is also slightly less. So we will do it just before your exam. Pakka. The slides and everything is made actually. We will do it. We will do it before your exam. We will do it. Okay? So chalo, for 0 order reaction, let us calculate, everybody. Yes, for 0 order reaction, let us do this. Unit of K, right? Unit of K, if we want to calculate it for 0 order reaction, everybody, look at it. What am I doing is concentration divided by time divided by, here what is going to be our concentration? Our concentration is raised to the power 0 because X plus Y is equal to 0. It's a 0 order reaction. Am I right, everybody? Very good. Anything raised to the power 0 is equal to 1. I hope that you all know this. Anything raised to the power 0 is equal to 1. That means that it is only concentration divided by time. That means that my unit will become mole, liter to the power minus 1, S to the power minus 1. Everybody agreed, guys? Everybody agreed? Now, you know what? There are certain times when you are given the unit and you are asked that what is the order of reaction? That is the kind of question that JEE will ask, everybody. These are the kind of question that JEE will ask. What will JEE ask? They will give you the unit and they will ask you that tell us what is the order of reaction. So if you know the unit, you can calculate the order of reaction like this in a snap. You don't even have to pick up your pen and you can just, click on it. Cool, alright, everybody, chalo. Now let us calculate it for the first order reaction, everybody. For first order reaction, let us calculate unit of K. I'm very happy that you guys already know it. Money Happy Rowan, you guys are doing amazing. Everybody keep answering. That is something that, you know, definitely increases my morale as well. So unit of K is equal to, once again everyone, concentration divided by time divided by concentration to the power 1, because x plus y is supposed to be equal to 1. Am I right? So that means that I can solve this equation as concentration divided by time multiplied with 1 divided by concentration, isn't it? So concentration has been cancelled. That means that it is 1 divided by time. That means that it is s to the power minus 1, just second inverse, right? S to the power minus 1, absolutely easy peasy biryani tasty, very good. Let us come to unit of K for second order, everybody. Unit of K for second order, everyone. So it will be concentration divided by time, concentration raised to the power square, isn't it? So one concentration will be getting cancelled, correct? Now that means that it will be mole to the power minus 1 L, because see, we know that mole L to the power minus 1, but here if L is minus 1, as it comes up, it will become L, right? So mole to the power minus 1, L will remain as it is, and S to the power minus 1, this, my dear student, is your unit. Don't get confused. It is very easy to get confused between second order and zero order. Please make sure that you know what is the difference between the two. Don't get confused. Such kind of questions may come in your JEE, okay? Now guys, before we move forward towards molecularity, let us understand what is the difference between an elementary and a complex reaction. An elementary reaction is usually a single step reaction, okay? Alright, and here what happens is the rate law is given according to the law of mass action, okay? How is it given? It is given as law of mass action, and law of mass action is something that we will be studying in your, yeah, Tanishka, that too. Obviously, that too. Yes, you have just, you have just made it the general form. Yes, that is the general form. Absolutely right. Yes. Now, law of mass action is something that we will be studying in the equilibrium chapter. I have it already. Don't worry about it. But tomorrow when I have a little longer time, at that point of time, I'll be taking you through it. Okay. All right. Complex reactions, there are number of elementary steps that are involved in a complex reaction, okay? And here rate law is given as per the slowest step. The slowest step is also called as the rate determining step, or as we like to abbreviate it and call it RDS, not RDX, RDS, okay? We have RDS here, okay? Now this is an example of a complex reaction. All right, this is an example of a complex reaction. Do you know that the order of this reaction, everybody, if you check it out, see, 6 plus 3 is what? 9 plus 1 is 10. Does it not look like the order of the reaction here is 10? But guess what? This is a second order reaction. This is a second order reaction, my dear people. Yes, this it looks like a 10th order reaction, isn't it? 6 is the molecularity here. 3 moles, right? So 6 plus 3 plus 9 plus 1, 10. 10 is the order of the reaction. That's how it looks like. But like I said, everybody, like I said, everyone, like I said, everybody, what did I say? I said that order of a reaction is experimentally determined. It is not mandatory that X and Y are going to be equal to the stoichiometric coefficient, my dear student. Gotcha? Simple and easy peasy, everybody. This is a second order reaction, all right? And now, my dear students, we come across something that is called as molecularity. So what really is molecularity, everyone? When we talk about molecularity, we understand basically molecularity is the number of reacting species which are taking part in an elementary reaction which may collide. So you all know this, right? How does a chemical reaction happen? In a chemical reaction, obviously the atoms and the molecule collide. How many of you have watched the movie Oppenheimer? And Oppenheimer has also received 7 Oscars. Yesterday I was watching the Oscars, everybody. Yes. Did you notice that? Yes. And in Oppenheimer, have you seen that there are a lot of chemical reactions, not chemical reactions, nuclear chemistry that they try to show you. A little bit of nuclear chemistry you will watch, and there are a lot of collisions that they show you, haven't you seen? And in this chapter, yes, my dear students, we will be learning about collision theory as well. We will also be learning about something that is called as effective collision. So if you have watched Oppenheimer, it does make sense to us even more right now, isn't it? That yes, there will be collision. Who will be colliding? The species, the reacting species, they will be colliding. And by the way, when we talk about collision theory, in some time we will be talking about it, we will also understand that the collisions, it's not just, drum. It's not just this. There is also something called as effective collision. It cannot be just this. It has to be effective. The collision can also happen like this, but this is not effective. See, I'm not able to collide it like this. But this, when I do, there is an effective collision. So yes, that also depends, everybody. Yes, alright. So when they collide, oh, by the way, they have to bring a chemical reaction. Like I just told you, right? Effective collision. Effective collision will bring a chemical reaction. There are also collisions where there will be collision, but there is no chemical reaction that has been generated because the collision was not effective. I hope that you guys understood this, everybody. Now, it is always a whole number, guys. Molecularity cannot be a fraction. Molecularity cannot be a negative number. Molecularity has to be a whole number. That means that it can, oh, by the way, it can only go up to 3. Molecularity can only go up to 3. Molecularity will not exceed 3. Yes, and it has no meaning for a complex reaction. That means that it is only applicable for your elementary reaction. Yes, it only is acceptable for elementary reaction. For a complex reaction, we do not talk about molecularity. Now we come across something that is called a pseudo first order chemical reaction. Those reactions, okay, those reactions that are made to behave like a first order reaction. By how do we do? How do we make them behave like a first order reaction? Just by changing, just by tweaking the conditions. Like maybe one of the reacting material can be present in excess. One of the material can be in a very, very, very less one. Yes, one of the or is maintained at a constant concentration. Then we might get a pseudo first order reaction. Okay. And right here, that is there. The example is there in your NCERT book, guys. Again, to shorten up the class, I am not writing the examples. There are many examples. You must have also seen that those examples are there in your NCERT. That's why I skipped it. One example is hydrolysis of ethyl acetate, hydrolysis of ester. You must have seen it. Hydrolysis of cane sugar, that is sucrose. Yes, absolutely, guys. And now the most important part of the chapter is right here, everybody. If you give me the next bit of 20 minutes of your time, everyone, we are going to finish this. Are you all with me, everyone? Are you all with me, guys? Yes, everybody, are you all with me? Are you all with me, guys? Shall we start with integrated rate law or integrated rate equation? Yes, yes. Yes, Mani, you are right, bacha. You are right, okay? You are right. Mani, you already know. Very good. So proud of you that you already know a lot of things, bacha. Chalo. So, integrated rate law, everyone. I hope that you all are with me. That means that what are we going to do here? We are going to integrate the differential rate equation. I made it look like so important, but it is just easy peasy biryani tasty, everybody. What is it? We are going to integrate the differential rate equation. Okay, integrate the differential rate equation to give a relation between measured experimental data, to give a relation between measured experimental data, guys. Okay, that means concentration at different times and rate constant. Okay, concentration at different times and rate constant. All right, yes, okay. For a parallel first order reaction, is parallel first order reaction in syllabus? Oh, I have forgotten, bacha. I'll have to check it out, Nikhil. I am so sorry, it has completely escaped my mind. I'll have to check the syllabus and let you know. Okay, but anyway, we will be doing it. We will study about it. I'll tell you. Okay, I'll tell you. Don't worry about it. Yes, I'll tell you. Chalo, guys. Now, let us integrate this, okay? Let us integrate it for the first order. Shall we do it? Yes. Oh, sorry, for zero order. So, let us start with zero order, everyone. Let us start with zero order. For zero order, let us integrate the rate of equation. So, first of all, everybody, you tell me what is the rate, guys? The differential rate law that we studied. The differential rate law that we had, we know that rate is equal to minus dr divided by dt. है ना? Very good. And that was equal to rate constant k multiplied with r to the power 0. If r is to the power 0, anything to the power 0 is equal to 1. So that means that it is just equal to k. Am I right, everybody? Now we need to integrate it, right? Now what do we need to do? We need to integrate it, everybody. So what are we going to do? Check it out. Yes. So we will take this differential rate law and we are going to integrate it. Okay. So mathematics, simple mathematics, what are we going to do? Minus d capital R divided by dt is equal to integration of R. Okay. Can we do this? We can do this. All right. Yes. Okay, everybody. No, not R. Sorry. Not R here. Minus dr by dt here, kr. So here let us just write here k. Okay. Now what are we going to do is we are going to separate the terms. One side let us just keep here. Let us just keep here dr here. Okay. And what we can do is let us take minus k outside and here we will integrate dt. Can we do this? Yes, we can do this. Hana? Yes, we can do this. Now if I integrate this, what will I be getting, my dear students? After integration, I will be getting concentration of R, that is R here, is equal to minus Kt. K is a constant, plus I will be getting a constant, everybody, yes? Now because there is a constant, everyone, because there is a constant, I need to find out the value of the constant, okay? So let us tweak it a little bit, okay? Let us approach it in a different way, okay? How do we approach it in a different way, everyone? Let us approach it in a different way. So imagine that at time is equal to 0. At time is equal to 0, I must have taken an initial concentration, right? I must have taken an initial concentration. So I am saying that my reactant concentration was initial concentration R naught. Can I do this? I can do this. Yes, I can do this, everybody. So if I put this value here, then what will happen? I will get R naught is equal to 0 plus constant. Yes. That means that my constant itself is equal to R naught. My constant itself is equal to R naught, everybody. Yes. Now that means that this equation, this particular equation, now it becomes what? This particular equation now becomes capital R is equal to minus Kt plus R naught, everybody. Yes, pseudo first order is done, bacha. Pseudo first order reaction is done, money. Okay. Yes, guys. Yes. So this is for zero order. This is for zero order. Capital R is equal to minus Kt plus R naught. Am I getting this? Very good. If I compare this with y is equal to mx plus c, everyone. Can I do that? Can I do that? If I compare this with y is equal to mx plus c, c is going to be what, guys? C is going to be what? C is going to be my intercept, right? Compare this, what will you be getting? C is your intercept. So now if I want to draw the graph, guys, okay, let us draw the graph here, everybody. Let us draw the graph here. I'm going to draw the graph. See, I have one line. This is my x-axis. Okay, and here, oh, this is a new thing that I figured out on my iPad. Okay, this is a new thing that I've just figured out, that I can draw straight lines and I don't have to be that failed, I don't have to be the failed artist all the time, everybody. Yes, so guys, here, see, check it out. Okay, now if I draw the graph, what will I see? I will see that time will be on the x-axis, concentration will be on the y-axis, and the line that I'm talking about, that is going to be somewhat like this. And this part, everybody, okay, let me join this. Array. Gone. I'm gonna have to draw this again, guys. 1 second, give me a minute. Yes. Okay. So this is going to be your graph, and right here, my dear students, you will see that this particular part, this is your intercept, that is your R naught. Clear, everyone? Yes, clear, everybody. I'm a perfectionist, not at all, everybody, not at all, actually. Not at all. But yeah, I recently found it out, so I'm very happy about it, that yay, I can do this. So this, my dear student, is your zero order integrated rate equation graph. Please do follow the graphs. The graphs are very, very, very important. All right, everybody. Now guys, what are we going to do? I'm going to draw a line here just to separate it out, okay, just to separate it out, because we are going to now study about what we are going to study. What do you call it? Now we're going to go for first order rate equation. Okay? We're going to go for first order, everybody. So chalo, first order, everyone, first order, right here we go. We go. Now we are going to derive it for first order. Are you all with me, guys? Chalo. Now for first order, everybody, we all know that rate is equal to, I will take a session on equilibrium. I think it is tomorrow, bacha. You just have to give me a time, yeah? You just have to give me a little bit time. See, today I only had 2 hours. That's why I did not take equilibrium, because once I take equilibrium, I'll take both chemical and ionic together. So I will require 3 to 4 hours. Today the channel was not free for 3 to 4 hours. After this, Durgesh ma'am will be taking a session. Then Namrata ma'am will also be taking a session. I had 2 hours. So in 2 hours, I thought I can finish chemical kinetics and I did not want to waste the time. Okay? But money, chemical equilibrium will happen. Chill Mari. Absolutely it will happen. Pakka promise, ma kasam. Okay? Chalo. Rate is equal to minus D. We know that it is dr divided by dt. Hai na? Everybody great. Now because we are doing it for first order, so I can write it as kr to the power 1. Correct? Everybody great. Now I'm going to do what? I'm going to integrate, everybody. So when I integrate, what will I get? What I'm going to do is, see, I'll bring this r, this r, everybody, do you see this r? This r I'm going to bring it here, okay, this side. Why? Because integrate karne mein it will be easier, right? To integrate it will be easier. So what am I going to do is, I'm going to write it as dr divided by r is equal to minus k dt, isn't it? That's what it is, and everybody knows it. So 1 by r. When you integrate 1 by r, what will you be getting, guys? You will be getting ln of r, right? Ln of r is equal to minus kt plus some constant, everybody. And similarly, what are we going to do? We are going to take at t is equal to 0, when time was 0, my concentration of r was some initial concentration, let us suppose r naught. Same way, if we put it here, so we will see that it will be ln of r naught is equal to 0 plus c, everybody. Yes, 0 plus c, everyone. Yes, right, everybody. So that means that from here I can clearly identify that c is equal to ln of r naught. C is equal to ln of r naught. Am I right, everybody? Very good. Okay. Now coming to the next step, everybody, So what am I going to do? We have calculated ln of r naught is equal to, c is equal to ln of r naught. Great. So now if I put this value in that equation, in the previous equation, now what will I get? Okay, 1 second, sorry. Let me change the color so that you know that this is the extra part that we are doing, okay? So here what will you get? You will be getting ln of r, okay? Natural log of r is equal to minus kt plus ln of r naught. That's my constant. Yes. Similarly, here, once again, everybody, what am I going to do? Compare this with y is equal to mx plus c. Compare this with y is equal to mx plus c. And what will we get? Yes, if we compare this with y is equal to mx plus c, my dear students, what is it that am I going to get? I am going to get it as c. ln of r, I can write it as ln of r, minus I can write it as ln of r naught. Can I not do that? I can do that, right? Minus here it will be kt. Correct, everybody? Yes. Am I writing it now? Am I writing it clearly? Very good. Now see, everybody, this ln, natural log, can be taken common. So r divided by r naught is equal to minus kt. Correct hai? Correct hai? What if I want to convert it to log base 10 now? I can do that. Vim. Chemistry and its vim, everybody. So what am I going to do now? I am going to write it as 2.303 log base 10, and here I will find that it will be r divided by r naught. That will be equal to minus kt. Am I right, everybody? This can also be taken. Correct. And this equation now, okay, not this equation. Let us just make it a little more, let us just tweak it a little bit more, okay? Just tweak it a little bit more. What will we see here? We will see that log R divided by R naught. Let us take all the constant to that side. So it will be minus KT divided by 2.303, and this also we can compare it with y is equal to mx plus c, right? This also let's compare it with y is equal to mx plus c. Now you know what will we get? You will be getting, my dear students, here you will be getting two graphs. Chalo, let us check it out. Okay, two graphs, everybody. Here I'm going to draw the graphs. Arey? Oh, sorry. Okay, chalo, okay. Drawing the graph, guys. Moving this side. Yes, final equation. This is enough. This is enough. Absolutely, this is enough. Okay. Just a second, guys. Let me draw the graph here. Okay, now what will happen is, for one, I'm just going to draw the graph because I remember it. Okay, I remember it, so I'm gonna draw it like this. Okay, this is one graph, and the second graph will be looking like the previous one, like this. Okay, all right, everybody. Now you will ask me, ma'am, what is the difference? Why did we draw two graphs, everybody? In the x-axis we are taking time on both the sides, okay? Time on both the graph, okay? But in the y-axis there are differences. In the first one we are taking ln of r, okay? We are taking natural log r, okay? All right, everybody? Yes. So here you see that the slope is minus k. Minus k is your slope. All right, and what is your intercept? But choose your intercepts become ln of r naught. Okay, at this point here, what are we taking? Now we are taking log r divided by, no, what am I doing is I'm going to change it. Okay, I'm going to change it. I'm going to write log r naught divided by r. Log r naught divided by r, if I take, then see here. Okay, moving aside, everybody, what do you see? You see minus kt, right? You see minus kt. But do you see that I have changed it? I have written it as log r naught divided by r. I have not taken it as log r by r naught. Log r naught divided by r. Hence, my slope will become positive, everybody. And this time, my slope is equal to k divided by 2.303. Please tell me that did you guys understand or not? Please check it out, everybody. Take a little time and try and understand this, everybody. Yes, the second graph is completely not visible. Okay, now what about now? What about now? Now can you see it? Now can you see it? Please take some time and look at this. Please take some time and look at this, everybody. This is easy peasy, crystal clear, everyone. For everybody, is this clear, guys? Now is it clear? What did I do? I have told you, see, here it was log r divided by r naught. Hence we got minus kt. Hence we got minus kt divided by 2.3. But if I reverse it, if I reverse this part, it becomes r naught by r. Hence it will become k divided by 2.303. I hope this is absolutely crystal clear, guys. Yes. Happy Mowgli? I suppose perhaps for you it is no more confusing. Please let me know if it is no more confusing. By the way, I do require a little bit of extra space, everyone. We have I suppose we had an extra page here. Yes. Now here we are. Okay, guys, first order is over, second order is over, and my scale mark is gone. just making it a little more perfect, because this note is going to come to you, right? You guys are going to get this note, so that's why I do not want to mess it up at all, and I want to make sure that it is absolutely perfect for you all. All right, everybody. Yes. Okay. So guys, we are at 12:34. You give me another 20 minutes, we will be done with this chapter completely. Okay, we will be done with this chapter. Now, my dear people, can we come to half-life, everybody? Chalo, let us come to half-life, everyone. Shall we? Thank you so much. Mowgli, happy Mowgli, was that compliment for you? Was that compliment for, oh, was that compliment for me? Thank you so much if it was for me. You know what, I've taken it, so thank you so much. Okay guys, PYQ coming up. We have already done, right? We have solved 3 questions already. There are more questions. You wanna see? You wanna see? If you do not believe me, see here. We have one more question. Here, see, JEE Mains 2023. Yes. See, JEE Mains 2023. Yes. There are more questions, guys. There are more questions. See, there are more questions, everybody. This is 2022. This is 2022. This is 2022. This is 2022. So there are more questions, everybody. There are more questions. Okay. Just wait. Just wait. We'll come to that. See, everything is here. Everything is here. You need not worry, guys. You need not worry. I have prepared it all for you. Okay. Supriya, how do we know whether a reaction takes place in single step or not? Very good question. Anybody else you want to answer? Mani, Tanishka, do you guys want to answer? How do we know whether a reaction takes place in single step or not? I think that Mani and Tanishka will be able to answer. Chalo, I'm giving you this assignment, everybody. You find it out. I really want to know. If you find it out, I promise, I swear to God, you will never in your life forget it. Beautiful question, no problem. It's not stupid at all. Very beautiful question. Mani and Tanishka giving you this assignment, or anybody else, anybody in the class who can answer this, you will get, virtually, you will get 16,000 rupees. Virtually. Virtually. I don't have the money to give you 16,000. Virtually, everybody. Yes, very good. Amazing. Amazing. Very, very, very good. You guys are doing an outstanding job. Tanishka, happy Mowgli, Supriya, you have your answer. You can look at the order, you can look at the reactants, and you will find out if it is a complex reaction or if it is an elementary reaction. No, Sumati, you do not memorize. You can memorize the order of the reaction, right? I'll take a session on that. Don't worry. I'll take a session on that. Okay. Very good. KKB has also answered. See? KKB has also answered. Yes, order is equal to molecularity, then single step. Very good. Amazing. Mani, yes. If the reaction is elementary reaction or not, how do you understand? How do you look at the reaction and find out? Chalo. Guys, you guys have answered. Very good. Well done, Supriya. I hope that your answer, your doubt is clear. Now, guys, let us move on towards half-life. What is half-life? What is half-life? The time in which the concentration of a reactant is reduced to 1/2. Okay? Yes, so let us write that down just so that you are not confused and you have everything. So the time in which the concentration of a reactant is reduced, okay? The time in which the concentration of a reaction is reduced to 1/2 of its initial concentration. That, my dear student, is called as your half-life. How do you denote it? You denote half-life with T1/2. That is T half. Okay. Now let us calculate it for T half. T half for zero order, everybody. Okay, T half for zero order, everyone. How do you calculate it? T half for zero order. It is very simple and easy. Rate is equal to, you all know that it is K R to the power 0. That means it is K, isn't it? Because R to the power 0 is equal to 1. Absolutely right. Very good. That means that it is minus dr divided by dt is equal to K. Am I right, everybody? Very good. Okay. So I'm deriving it for you. Okay. I'm deriving it for you. Now, everybody, that means that R is equal to, we know, just from the integrated rate law, we have just calculated that KT plus R naught. Remember, R naught was the constant, everybody. R naught was the constant, everyone. Just some time back only we have done this. Yes, if you remember, everyone. Yes, if you remember, we have just done this. So that means now we are saying that the initial concentration will become half. So that means my R, my concentration of reactant is going to be initial concentration divided by 2. Agreed, everyone? Agreed, everybody? Yes, agreed, everybody? R naught divided by 2 is equal to minus KT. T is also going to be half. So T half, yes, T half plus everyone here R naught. I'm going to write this. Now everybody tell me. So let's just, tweak it a little bit. What will we get? We will get K T half. Yes, K T half is equal to, everybody tell me, can I write it as R naught minus R naught divided by 2? And if I do that, see, this is very simple. 1 minus half will become what? 1 minus half will become half. So it will be R naught divided by 2. That means that T half is equal to R naught divided by 2. R naught divided by 2. Guys, this is clear. Is this clear to you all? Is the derivation absolutely fine? Yes, is the derivation absolutely fine, everybody? Did you guys understand this? Yes, did you guys understand this? Very good. Okay, chalo, let us move on, everyone. Okay, I'll need another one because gas phase reaction I haven't taught you, right? I haven't taught you gas phase reaction. So yes, I'll have to do gas phase reaction as well. Yes. Okay, guys. Now let us take a look at half-life for first order. Half-life for first order. Half-life for first order reaction, everybody, let us calculate it. Once again, we know that rate is equal to K multiplied with R to the power 1. Yes, and you have minus dr by dt is equal to K and R, because R to the power 1 can be written as R1, right? Now from integrated law, we know that K is equal to 2.303 divided by T log of R naught divided by R. Am I right, everybody? Yes. Isn't that what it is? Isn't that what it is, everybody? I'm going a little fast, everybody. I hope that you guys are understanding. Yes? I hope that you guys are understanding. This is clear? Yes? This is from integrated law, guys. This is from integrated law. Let me write it a little clearly. Okay? So now K is equal to 2.303 divided by T half. We are taking, yes, T half if we take, then here we will get R naught divided by, my concentration of reactant is going to be R naught divided by 2. Am I right, everybody? Yes, very good. Okay, coming this side, everyone, coming this side. Okay, coming to this side. Now see what will happen. Now see what will happen. Okay, so that means now my T half is equal to 2.303 divided by K, cross multiplication. So K, yes, and here log R naught by 2. So that means it will be log of 2. Clear, everybody? It will be log of 2. If you calculate this, you find that T half is equal to 0.693 divided by K. And this, my dear student, is a very important term because this is utilized in majority of the numericals that you will be doing. Okay, and here is a conclusion. The conclusion is that T half is proportional to 1 divided by K. Remember this also. Okay, everybody, this is clear, guys. Is this clear, guys? EPBT, quickly write EPBT, everyone. Quickly write EPBT. Acha. Now we come across another thing, that is first order of gas phase reaction, everyone. Okay, first order of gas phase reaction. What do you mean by that? First order. Why are we doing gas phase separately? We are doing gas phase separately because when we come across gas phase, we are not taking molar concentration. We cannot take concentration at that point of time. Yes, my dear student, you guessed it right. We will have to take the pressure. Yes, we will take the pressure. Okay. So first order gas phase reaction. Here guys, let us suppose you have a reactant which is A and it is in gaseous state, which forms B which is in gaseous state, plus you have C which is also in gaseous state. Okay, so now what are you going to do? Are you going to take the concentration? Not at all. You will be taking pressure of A, you will be taking pressure of B, you will be taking pressure of C. Now suppose everybody at time is equal to 0. What do you have? You have, let's say, P1 atmospheric pressure. But for B and C you have 0 and 0. Make sense? Right? Make sense? So at this point everybody, the total pressure is equal to P1. Make sense? Total pressure is equal to P1. Yes? Yes everybody? Very good. Okay. Clear hai till here? But at time is equal to T. After some time has passed. Now let's say the pressure for B and C is here X and X. That means the pressure for A will be P1 minus X ATM. Correct hai? Correct hai everybody? Yes. Achha, from here now I can write that PA is equal to P1 minus X, isn't it? I also know that P1 minus X, or I can write everybody, check it out guys, okay, what can I do is P1 minus, can I write it as PT minus P1? Can I do this? PT minus P1, I can do this, right? That means that I can write it as 2P1 minus PT. Yes? Yes, right? How did I calculate it? Chalo, one more time, everybody. Come this side. See, for this part right here, now what is going to be my P total? My P total is going to be P1 minus X plus X plus X, isn't it? Plus X, yes. So that means that it will be P1 plus 2X. No, not 2X, sorry. Not 2X. It won't be 2X. So this one get cancelled. So P1 plus X, am I right? That means that X is equal to PT minus P1, and that is the one thing that I have utilized here. Everybody check it out guys. Yes. So from here, after doing all of these, now everybody check it out. How do we write it for K? So K is going to be 2.303 divided by T log, okay, log P1 divided by PA, okay. This will be equal to 2.303 divided by T log of P1 divided by, what is PA? I've just calculated 2P1 minus PT, isn't it? So 2P1 minus PT, and this, my dear student, is your why P1 minus X. Nikhil, see. Why P1 minus X? P1 plus X, not minus X. How will it be 2X, bacha? How will it be 2X? I would like to grab your attention, draw your attention towards this plus C. P1 minus X plus X. So this and this gets cancelled. So there will be P1 plus X only remaining. P1 plus X. That means that X is equal to PT minus P1, right? Yes. Okay. Now, why am I taking P1 by PA? I can take it like this, no? Because here, see P1. Here it is P1, and then I want to derive it for PA. Because this is the calculation that I have done, right? And we all can see that, yes. We all can see that, everybody. So this is done, everybody. Clear hai? Alright guys, alright. Now let us quickly come across the temperature coefficient and Arrhenius equation. That means we are almost about to be done, everybody. Yes, and I would quickly like to tell Durgesh ma'am to shift her class to 115. Can I just do that? I'll just quickly do that, okay? Okay, I have asked Durgesh ma'am to shift her class. I am taking. Yeah. Oh, she has done it. She has done it at 1:30. Okay. She has done it at 1:30. Chalo, ठीक है. Okay. All right, guys. All right, everybody. Whew. Govindu, please बच्चा go back and watch it again. ठीक है? चलो, let's quickly do it because Durgesh ma'am also has to take a session. ठीक है? She also has to take a session. Let's quickly finish it. चलो, everybody. Now we come across temperature coefficient. Temperature coefficient. Why do we come across this term? Because it has been noted down that for any general chemical reaction, if the temperature increases by 10 degrees Celsius, then the rate constant is nearly doubled or tripled. It is nearly doubled or tripled, my dear students. So yes, and that is why you get temperature coefficient, we denote it by mu. Mu is equal to Kt plus 10 divided by Kt. This is a very important formula, and you can also write it as Kt2 divided by Kt1 is equal to mu to the power delta T by 10. Both of this formula are very important. However, Arrhenius equation is that equation which actually gives you the exact relation of rate constant and temperature coefficient. And the equation is K is equal to AE to the power minus EA divided by RT. Now what is K here? K is your rate constant. What is T here? T is your temperature in Kelvin. What is EA? Activation energy. And what is this A? This A is called as Arrhenius factor. It is called as pre-exponential factor. And by the way, my dear student, this pink term that you see, this E to the power minus EA by RT, you know what it represents? It represents the fraction of molecules that have kinetic energy which is greater than the activation energy. We will talk about activation energy. Yes, we will talk about activation energy right now. But before that, here is a logarithmic expression, everybody. Okay, and this is your logarithmic expression. Once again, this is also an important, very important formula. So guys, you know, from here, they will only ask you numericals. You do not need the derivation. You do not need to understand how we have come across here. All you need to know is the formula. These formulas you will have to memorize. These formulas will be coming in your exam again and again, letting you know previously it's not a prediction also. It's an in general term. I'm telling you that from chemical kinetics, they will be asking you questions related to this, everybody. Now, my dear student, if you ask me that what is an activation energy, everybody, okay? Temperature coefficient. Arey baba, T is there, no temperature in Kelvin. T is there in temperature Kelvin. So what are you doing? You are relating rate constant with temperature, isn't it? You are relating rate constant with temperature, and that's it. Arrhenius equation gives you a rate constant and temperature relation. Exact relation of temperature and rate constant. Cool? Alright, not coefficient. Temperature. Sorry. Acha, now. Logarithmic expression I have told you. Now I am going to tell you what is activation energy, everybody. So what happens is, whenever the reactants are there, right, these reactants, you will have to give them, you will have to provide them with some energy so that they get converted to the product. Okay, so that they get converted to the product, you will have to give them some bit of energy. And when you do that, you get a graph like this, everybody. Okay, you get a graph like this. Now what happens is, from this part, okay, from this part to this peak, okay. So you guys understand that, imagine that from reactants to product, imagine it's a mountain, okay. Imagine if it is a hill, then what happens, guys? Climbing up the hill is very much of a problem, isn't it? To climb the mountain, it's a very tedious task. You need the ropes, you need to, you know, have a stick or something to climb up, right? Am I right, everybody? But once you climb up, then coming down is very easy, right? Coming down is very easy, right, everybody? And once you come down, once the product is formed, generally we know that product, once they are formed, they are more stable because they have less energy. Because they have less energy, the product will always have lower energy. So my dear bachos, everyone, if you check it out, this particular part, okay, this particular part, this is your activation energy, EA, activation energy for the reactant to go forward. For the reaction to move forward, right? For the reaction to move forward, this is your activation energy. Hence, I have written here F. Hence I have written here F. ठीक है? ना रे बाबा, ना. Gravity is not reactant. Once you have pushed the reactants to have an effective collision, once they have gone through an effective collision, then forming the product is easy. So basically you have to give them some energy. Okay, understand it this way. Let's suppose analogy. Okay, I'm giving you an analogy. Guys, imagine that if you are an introvert, right? If you are an introvert, you will need some amount of a reinforcement for you to mingle with people. Otherwise, will you mingle? No, right? If I want to, okay, so even I do not go out. Okay, I hardly ever go out of my house. Why? Because I don't know, somehow too many people, they make me, it makes me very conscious, it makes me very suffocated. I do not like going out. I do not really like mingling with people. That's the truth. Okay? So unless and until somebody does not give me a reinforcement, unless and until they don't tell me that if you don't come, this is gonna happen, or if you don't come, you're going to miss out on this, or if you don't come, you are not going to make connections. Unless and until somebody does not tell me that I'm not going to go out. So that is my activation energy. That is my activation energy for me to go out. But once I go out, then I can mingle with people. Because then it's a switch. I know that, okay, I have to go out, I have to meet people. I can't just, sit in one corner. So once I go out, I can do that. But the going out, there is a push. To go out, there is a push. Somebody has to do that to me. You getting my point now? This is an analogy, guys. Yes? So for the reactants also to mingle, they're not going to mingle just like that, right? You need to give them an energy and tell them that, hey, we need an effective collision. We need an effective collision for a chemical reaction to occur. And once you provide them with that energy, then only the reaction will go forward, but you have to take it to a peak. Once you have taken it to a peak, you have given that enough energy that yes, now we can react. Once that is there, then it will come. Because it's camera, no. Because it's camera, you meet me in the public, I'll be like, hi. Okay, so what are you studying? Okay, bye, then have a nice day. I'll go like that. I'm very bad at it. I hardly ever open my social media. I had a public, public Instagram profile that I have. I think my students have, left following me now. They're leaving from my followers list because I hardly post anything. I forget about it. I completely forget about it. That's the truth. Anyway, all right, guys. So this, my dear student, yes, this is where you are forming the product. See, the formation of product. After the formation of product, everybody, you all know that the reactants, they become more stable. Okay, they become more stable. So from here to here, my dear student, what will this be? This will be the activation energy for backward reaction. Now, if you want the products to form the reactants, you will have to give more energy to make it form a reactant, isn't it? So this will be EAB. B means backward reaction, everybody. Cool hai? And this difference, bacha, this difference, everyone, do you see? How do I, so, chalo. This difference, do you see, everyone? This difference, this is called as your delta H. This is called as your delta H, everybody. Yes, delta H is E forward minus E backward, or E backward minus E forward, and this complete thing, okay, this is your threshold energy. Okay, this is your threshold energy. Okay, everybody. Acha, so this is for your exothermic process. Okay. Now for endothermic process, what will happen, guys? For endothermic process, what happens is the reactants, okay? Endothermic process, yeah. The reactants are here, and from here you go like this, and here is the product, okay? So this particular part, this is your activation energy for backward reaction, okay? This is your EA for forward reaction, okay? And this difference that you see right here, yes, this difference that you see, everybody, this is your delta H, everyone, okay? All right, this is your delta H, everybody, and that, my dear student, is for your endothermic process. Yes, guys, are we clear with it? Done? Okay, so let us solve a question, shall we? Let us solve the question. The question, everybody, is for a first order reaction, the time required for completion of 90% reaction is x times the half-life of the reaction. The value of x given ln of 10 is equal to 2.303 and log 2 is equal to 0.303. Okay. Yes, Nikhil, you are right, bacha. So you are done. Okay. So we are done. Now let us solve this, everybody. So we all know that k is equal to 2.303 divided by t log r naught divided by r here. Okay. Now we also know that t half is equal to 0.693 divided by k. That means that k is equal to 0.693 divided by t half, isn't it? Can we write like this? Yes, we can write like this. Now from here what we can do is, everybody, so 0.693 divided by t half is equal to 2.303 divided by t, and we know here that it will be log c. What is it given? 90% of the reaction. That means imagine that initially it was 100 minus 90 will be 10, and this particular term is equal to 1. So what will happen here? Everybody, we will be getting t is equal to 2.303 multiplied with t half divided by 0.693, isn't it? So that means that if you calculated 2.303 and 0.693, guys, calculated, t is equal to 3 point something, isn't it? 2.3 and this is 0.693. So yeah, it will be 3 point something t half. So 3.32, let us write 3.32, let us write here. That means option number C is correct. Option number C is correct. No problem. Here are the options, guys. First solving was important, so we have solved it. Yes. Done, guys? Chalo. Acha, now quickly let us go through collision theory, okay? What is collision theory? I kept telling you guys, collision. Collision means that per unit volume, okay? Per unit volume in per second, number of collisions that are happening, okay? Number of collisions that are happening, that is your collision frequency, okay? For A to B, from when the reactants are forming a product, there needs to be effective collision. And effective collision means, guys, you have to understand, see, collision can happen like this also, right? This can also be a collision. But at this point, you know what is happening? The reaction is not happening because this is not effective collision. For a collision to happen, this is your effective collision. This, let's say that head-on collision is the effective collision, isn't it? Head-on collision, let's say that it is the effective collision. So that is very important. And by the way, effective collision also depends on two things, that is energy barrier, and the second one is your orientation barrier, okay? Orientation barrier. So energy barrier, everybody, we have just understood, that was the activation energy part, and orientation barrier is this. Remember, I've just told you, yes. See, this way also collision can happen, but this is not this is not proper. When you make the collision happen like this, then maybe bonds are going to form and it will hold on to it. Okay? Alright, from here we come across something that is called as the probability or steric factor. That means that once that orientation barrier has been introduced, we come across something that is called as probability or steric factor, which is rate is equal to this. Right here we have introduced the probability factor. Right here we have introduced ZAB, that is the collision, the effective collision, and then it is the same simple as Arrhenius equation, e to the power minus EA by RT. Are we clear, guys? Everything is clear, everyone? Yes? Now shall we quickly solve some questions? Chalo, let us solve some questions. Yes, everybody? Let us solve some questions. So the question here is, the number of correct statement from the following is dash. Larger the activation energy, smaller is the value of the rate. So here, Z is collision frequency. Yes, Z is collision frequency. Sorry. Just to make it faster, everyone. Chalo. Let me just quickly come across. Rate is equal to ZAB. ZAB is your collision frequency. P is the probability or the steric factor, and e to the power minus EA by RT. R is your gas constant, T is your temperature, EA is your activation energy. From here there will be no questions asked related to derivation. It will always almost be theoretical questions, everybody. So you just have to know the formula. Thank you so much, Anno, thank you so much. Yes, bacha. Are we done? Now moving on here, see what we were talking about this question, isn't it? So we have K e to the power minus EA by RT. E to the power minus EA by RT, that means if EA increases, K will decrease. So yes, this, my dear student, is a true option. Yes, this is true. Yes. Supriya, mostly yes, maybe 1 or 2 chapters you will not find, but otherwise you will mostly find almost everything. Okay? You'll mostly find everything. Yes. Acha, now higher is the activation energy. Higher is the value of the temperature quotient or temperature coefficient. Temperature coefficient. Chalo, let us try and solve this, everybody. Let us try and solve this. Guys, are you all able to see this? If you are all able to see this, now check it out. For option B, okay, for option B, everyone, let us take a look at this. See, higher is the activation energy, higher is the value of the temperature coefficient. Although this is true, that means we know that ln of K is equal to ln of A minus EA divided by RT. We can write like this. If it is ln of K, that means it is 1 divided by K dk divided by dt, right? That means it will be equal to plus EA divided by RT square. Yes. So if EA increases, yes, if EA increases, do you think that the temperature coefficient will also increases? Yes, temperature coefficient will also increase here. That means this is also true, everybody. This is also true. At lower temperature, increase in temperature causes more change in the value of K than at higher temperature. This we cannot say, guys. This we cannot say at all. Okay, this is going to be false. A plot of ln of K versus 1 by T is a straight line slope with equal to minus EA by R. I think this is true, everyone. Slope of ln of K versus 1 by T, if you draw the graph, yes, it will be minus EA by R. So this is also true. The correct answer is yes. 3 is your correct answer. 3 is your correct answer, everyone. Okay? Okay, chalo. Moving on. Next question. For a reaction given below. For a reaction given below is the graph of ln K versus 1 by T. The activation energy for the reaction is equal to dash calorie per mole. Nearest integer you have to calculate, everybody. Nearest integer. So chalo, what do we know, guys? We all know that K is equal to A e to the power minus EA divided by RT. Okay. That means that ln of K is equal to minus EA divided by RT plus ln of A. I can write it like this, isn't it? So that means my slope is equal to, what is my slope? Slope is equal to EA divided by R. And from this graph, we can see that EA divided by R, it is going to be 20 divided by R is here 1 by K. 1 by T, sorry. Slope is equal to EA by R. So that means EA by R, slope is equal to EA by R. So 20, slope is equal to 20 and here it is 5. So 20 divided by 5. Now 5 4s are 20. So EA is equal to 4R. R value is given to you as 2 calories. So that means 4 multiplied with 2 is equal to 8 is the answer, everybody. Is 8 is the answer. 2 by 20 by 5. Yes or no? Yes. Slope is 20 by 5. Absolutely right. Yes. Great. Next question, everybody. For the given first order reaction, A to B, the half-life of the reaction is 0.3010 minute. Okay? The ratio of the initial concentration of the reactant to the concentration of the reactant at time 2 minute will be equal to, again, nearest integer everybody. So chalo, let us do it. Now we all know that t half is equal to 0.693 divided by k, isn't it? Yes. And t half that is given to you is, t half given to you is 0.30, 0.3010. Yes. That means if I want to calculate k, k will be equal to 0.693 divided by 0.3010. If you calculate this, how much will you be getting? 0.69, 0.3. It will be 2.30. It will be 2.30 or 2 point something, 2 point something, 2.30, 2.2. Thank you, Tanishka. 2.30. Yes. Now we also know that k is equal to 2.303 divided by t log what will happen? Log what was it? Log r naught by r, right? Initial concentration divided by this thing, or we can also write it as r naught by r. Let us write, okay, r naught by r, or rt. You can write r naught by rt. You can write, है ना? Once we do this, everybody, then what will happen? K value we already know, it is 2.30. That means 2.303 divided by t log, we can write it as r naught by r. So that means t is equal to, oh no, t is also given, guys. Sorry. Why t? T is also given, isn't it? T value is also given to you. Here. 2 minutes. So here we will write 2. Here we can write 2. That means that this will get cancelled, this will get cancelled. So 2 is equal to log r naught by r. And if I do this, that means that it will be r naught by r is equal to 10 to the power 2. Yes, 10 to the power 2 is equal to 100. Everybody, this is your answer. Am I right, everybody? Am I right, guys? Please check it out. Please check it out. Please check this out, guys. Done, everyone? Yes? Okay, guys. The next question, everybody. For a reaction A forms 2B plus C, the half-lives are 100 seconds and 50 seconds when the concentration of reactant A is 0.5 and 1.0 mole per liter respectively. The order of the reaction is, we need to find out the order, everyone. So, chalo. So we all know that T half can be proportional to 1 by r naught n to the power minus 1. Can we do this? Very good. Now T half is equal to 100 seconds. T half is equal to 100 seconds. If it is 100 seconds, then we know that it is given as concentration of reactant A. Acha, they are taking A. So let us take here A instead of R naught. Okay. Let us take here A. Let us take A naught. Okay. Let us take A naught here. Order is 0. Nahi bacha, order won't be 0. You will check it out. Order won't be 0. Order won't be 0. Why? Because if it is 0, then it will be mole, liter to the power minus 1, S to the power minus 1. Isn't it? So here, 100 seconds and you are given A naught is equal to 0.5. Isn't it? Very good. Another T half is given to you, which is 50 seconds, right? 50 seconds. If it is 50 seconds, then A naught is equal to 1. It is given, right? Okay. If that is the case, let me come this side. Yes. Here, okay, this side, sorry, what will happen is 100 divided by 50 I can do. Yes, 100 divided by 50 is equal to 1 divided by 0.5 n to the power minus 1. Huh? Okay. That means this cancel 5 and 2 here. So 2 is equal to 1 divided by 0.5 n to the power minus 1. This will also be 2 to the power n minus 1, right? Now if I want to do n minus 1 is equal to 1. So that means n is equal to 2, and that, my dear student, is your answer. I'll do one last question. Then the next question, shall I give it to you as homework, everybody? Or you know what? Let's give you this as homework. Chalo, let's give you this as homework because this is easy. This as homework, everybody. And I am going to give it to you as a last question. I'll do it. Okay, this question I'll do it. Chalo. For a first order reaction A forms B, the rate constant K is equal to 5.5 into 10 to the power whatever the time required for 67% completion of reaction is x into 10 to the power minus 1. times the half-life of the reaction. The value of x is dash dash dash. Okay, so what are we going to do? We all know that T half is equal to 0.693 divided by K. So that means 0.693 divided by, you can put the value of K, 5.5 into 10 to the power minus 14, isn't it? Yes. Calculate this everybody and tell me what is the answer. Calculate this and tell me what is the answer. Okay. Then what we can do is, now T half is equal to, no, not T half, sorry, T 67%. See, as per the question, T 67% here. T 67% is equal to first order reaction, right? First order reaction. So T is equal to 2.303 divided by K log 67% of the completion. 67% of the completion, that means initially 100. 100 minus 67 is how much? 33. 33. Yes. Okay. Alright. Let us go this side. Let us go this side. Now see what will happen is, see, 2.303 divided by 5.5 into 10 to the power minus 14, and log 100 divided by 33 will be how much? 100 divided by 33. 25 into 4, 25 into 4 is 133. That means that 3, isn't it? And log 3 value is given to you guys. Log 3 value is given to you in the question. So that means it will be log 3. So what we can do is multiply this with 0.4771. Calculate this and tell me what is the answer. Whatever answer, let's say this is x and this is y. Whatever answer you get, what you can do is, everybody, you do y is equal to, see, y is equal to x into 10 to the power minus 1, right? So x into 10 to the power minus 1, let us consider this to be z here. Z, multiply with z if you do. Multiply with z if you do. Okay. What will you get? You will be getting x into 10 to the power minus 1 is equal to y divided by z. If you do, you will get the answer, everybody. You will get the answer. Okay. This is how you are going to do. And with this note, everybody, we have come to the end of the session, everyone. Thank you so much. This is your Vedantu JEE English channel. I hope that top to bottom, everything that was there in this chapter, I've explained it all. Thank you so much. Yes, thank you so much. Stay tuned to the session. Durgesh ma'am will be taking a session after this, and after that you also have Nabamita ma'am session today. Thank you so much, everyone. With this note, Tara, bye-bye. I'll see you all very soon. Whatever questions or doubt you have, everyone, okay? Whatever questions or doubt you have, do not worry about it. You can write it in the chat box. I do see the comment section. I will try and explain it to you. Okay? Tara, bye-bye, everyone.